Hi students, today we are talking about fundamentals of organic chemistry, right? So very pure fundamentals under fundamentals of organic chemistry. So we are going to study about what is the carbon valency, right? And what is the representation, bond line formula. This is very important. Why? Because in most of the organic mechanisms we are using bond line formula, right? So what is the bond line formula and what is the hybridization of carbon atoms at different situations, and how to calculate number of sigma bonds and pi bonds. This is also very important, right? Next, after that we are going for what are the different types of carbon atoms in terms of what degree of carbon, like 1 degree, 2 degree, 3 degree and 4 degree, right? So like that, what about the different types of hydrogen atoms, different types of alcohols, amines, amides, okay, right? And what about the different types of halogen compounds, right? Next, what about the fundamental meaning of functional group and what is the homologous series, okay? And what about the types of organic compounds and what is the degree of unsaturation, what is the fundamental meaning of degree of unsaturation, and how we are calculating degree of unsaturation on the basis of what given molecular structure, and on the basis of what particular formula. One simple formula is there to calculate degree of unsaturation, okay? These are the very important things. After that we will go for IUPAC nomenclature, okay? So even though these are what fundamentals of organic chemistry, more questions are coming from these fundamentals of organic chemistry. Please don't neglect, please concentrate one by one, right? First we are talking about representation of organic molecules. So before going to representation of organic molecules, so first of all, what is the maximum covalency of carbon atom? Very important point. What is maximum covalency, maximum covalency of carbon? What is the answer for that? What is maximum covalency of carbon atom, right? Just I am writing here 4. That is the maximum covalency of carbon atom. So basically, to explain the bonding nature, we are going to chemical bonding. In chemical bonding, clearly we are writing what is the atomic number of the particular atom and what about the orbitals involving in the bond formation, and how we are getting what sigma bonds, how we are getting what pi bonds and all these things. But here I am not going to details of these things, right? Just I require here what is the carbon valency, right? And what type of orbitals are participating in the sigma bond formation, and how we are getting what pi bonds. These 3 points are what sufficient to understand the fundamentals of organic chemistry, right? First of all, what is the maximum covalency of carbon atom? Maximum covalency is 4. What is the meaning of maximum covalency 4? Maximum covalency 4 nothing but around the carbon atom maximum we can arrange how many number of bonds. Maximum we can arrange 4 bonds around the carbon atom. That's the meaning of covalency, right? So these 4 bonds, that may be in the form of what, sigma bonds or sigma and pi bonds combination, right? First I am writing like this around this carbon atom, okay? Here I am trying to arrange 4 bonds, 1 2 3 4. What is the covalence of that carbon atom? 4. How many bonds present around the carbon atom? So we know that only single bond is present, that should be taken as what, sigma bond. And sometimes we are using double bond. So once double bond is given, now out of these 2 bonds, one should be what, sigma bond. And what about another bond? Second bond should be taken as what, pi bond. And for example, if triple bond is given, right, triple bond is given, in triple bond again here one should be what, sigma bond. And what about remaining 2 bonds? These 2 bonds are what, said to be pi bonds. These are very basics, fundamental basics, okay, very important also, right? So once again, if only one bond is given, that should be taken as what, sigma bond. So in general we are talking about CC bonds and CH bonds like that. And once a double bond is given, in double bond how many sigma and how many pi? One sigma bond and one pi bond. And come to triple bond, one sigma bond and 2 pi bonds, okay? Once again, what is the carbon valency? Maximum covalence of carbon is 4. We can arrange 4 bonds around the carbon atom. Now first I am taking here sigma, 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 sigma. 4 sigma bonds are there. For example, around the carbon atom, sometimes we are taking like this carbon atom, and here I am taking one more carbon atom. So in between these two, now 2 bonds I am writing like this, 2 bonds, and remaining 2 bonds left side and remaining 2 bonds right side, okay? 2 carbon atoms are there. So now here out of these 4 bonds, how many sigma and how many pi bonds are present? So let us take this left side carbon atom. Here sigma bond, here also sigma bond, and here out of 2 bonds, one is sigma, another one should be what? Pi bond. Okay. Next one, around this carbon atom, sigma, sigma, here sigma, again pi bond. That means around this carbon we have how many sigma bonds? We have 3 sigma bonds. And how many pi bonds? 1 pi bond. And right side around this carbon atom, again 3 sigma bonds are there and 1 pi bond is present, right? So that is the arrangement of bonds around the carbon atom. Next one, for example, molecule is given like this: C triple bond C, C triple bond C. Left side and right side bonds are what given like this. Now just you look at this carbon atom. Around this carbon, what is bond? Sigma bond, and here 3 bonds are there. Out of 3 bonds, how many bonds are sigma? 1 sigma, and remaining these 2 bonds are what? Pi bonds. Clear? Here also same thing. Around this carbon atom, sigma, and remaining 2 are what? Pi bonds. Here we are not exceeding carbon valency 4. Maximum we are trying to arrange 4 bonds around the carbon atom. Sometimes only we are taking what? Sigma bonds, and sometimes combination of sigma and pi bonds. Okay, but we are not exceeding more than 4. Now here sigma, sigma and 2 pi bonds are there. Around this carbon atom, sigma, sigma, 2 pi bonds are there. Okay, that is the covalency of the carbon atom, maximum covalency of the carbon atom. Okay, what is the covalency? Maximum covalency of carbon atom? 4. That is the first important point. Second important point, okay, sigma bonds are formed by. We will discuss very clearly in chemical bonding. Just you remember these 2 points. Sigma bonds are formed by sigma bonds. Sigma bonds are formed by hybrid orbitals. Hybrid orbitals. Sigma bonds are formed by hybrid orbitals. Next one, pi bonds. Pi bonds are formed by side wave overlapping of orbitals. Side wave overlapping of orbitals. You remember this point. Sigma bonds are formed by hybrid orbitals, and pi bonds are formed by side wave overlapping of orbitals, and pi bonds are formed by unhybridized orbitals. That is very, very important. Okay, sigma bonds are formed by hybrid orbitals, pi bonds are formed by side wave overlapping of orbitals. Okay, side wave overlapping of orbitals. We can also write unhybridized orbitals. Unhybridized orbitals. Very, very important points. Okay, so once again, sigma bonds are formed by hybrid orbitals, and pi bonds are formed by side wave overlapping of orbitals, and these orbitals are hybrid orbitals or unhybridized orbitals, right? Next one, if you want to write hybridization of any carbon atom or any atom, just to remember like this, right? Here in organic chemistry, only 3 hybridizations are sufficient: sp hybridization, sp2 hybridization, and sp3 hybridization. But when you are going to inorganic molecules, there we are going up to sp3d3 hybridization, but up to sp3d3 hybridization we don't need in organic chemistry. In organic chemistry, 3 hybridizations are sufficient: sp, sp2 and sp3, right? So if you want to write these hybridization, now you remember this point. First point, hybridization. For example, only 1 sigma bond is present. Okay, 1 sigma bond is present, or you write like this: number of sigma bonds. Number of sigma bonds equals to 2, for example. Next, second case, if number of sigma bonds equals to 3. Third case, if number of sigma bonds equals to 4. Okay, number of sigma bonds equals to 4. We are considering only sigma bonds. We are considering only sigma bonds, okay, but not pi bonds. If number of sigma bonds equals to 2, and we know that sigma bonds are formed by hybrid orbitals or unhybridized orbitals. Sigma bonds are formed by hybrid orbitals. Here how many hybrid orbitals? If you are having two sigma bonds, these two sigma bonds are formed by two hybrid orbitals, one s orbital and one p orbital. So what is the hybridization? Sp hybridization. Here three bonds are there. Now three bonds nothing but we require three hybrid orbitals, one s orbital and remaining two p orbitals. What is the hybridization? sp2. And here four s and three p orbitals we require. What is the hybridization? sp3. Now these three hybridizations are sufficient throughout the organic chemistry. We don't want sp3 d hybridization, sp3 d2, sp3 d3. We don't want these hybridizations. Organic chemistry point of view, these three hybridizations are sufficient. So what are the three hybridizations? sp, sp2 and sp3. Once two sigma bonds are there around the atom, what is the hybridization? sp, right? Next one, around the atom, three sigma bonds are present. Then what is the hybridization? sp2 and four sigma bonds are there. sp3 hybridization, right? And one more important point. For example, we have s, p, p and p. One s orbital, three p orbitals I am taking. Again s, p and p. Okay, right. Here, for example, if I am using these two orbitals for hybridization, and here I am using these three orbitals for hybridization. Here I am using four orbitals for hybridization. Then here what is the hybridization? By the combination of s and p. What is the hybridization? sp. And here what is the hybridization? Simple. One s orbital, two p orbitals are there. What is the hybridization? sp2. Clear? Here four orbitals we are using. No one is left. What is the hybridization? sp3 hybridization. Clear? sp, sp2 and sp3. You remember this point. For example, out of four orbitals, s, p, pp. Ppp nothing but px, py, pz. Okay. So p orbital, actually three degenerate orbitals are there, like px orbital, py orbital and pz orbital. Okay, right. Now just you tell me this point. Here I am asking, what are the number of pure orbitals? Number of pure orbitals. Now in sp hybridization, if two orbitals are involved in hybridization out of s, px, py and pz, next how many number of pure orbitals are available? Out of four, s and p participating in hybridization, and what about these two? These are what? Pure p orbitals. Okay, yes, number of pure p orbitals, number of pure p orbitals equals to how many? 2. Next one, number of pure, better to write here, p orbitals. 1 second. Yeah, pure p orbitals. I don't know whether it is visible or not. Just remember this point. Number of pure p orbitals 2. Here number of pure p orbitals. Number of pure p orbitals equals to 1. Now this is left, not participating in hybridization. Here number of pure p orbitals equals to how many? 0. Clear? In first one, number of pure p orbitals 2. Here 1. Here 0. Okay, these are the very fundamental basics for organic chemistry, right? Next one, let us start first concept. Now this is the concept 1. Remember, in the first concept, I am writing that representation of organic molecules by bond line formula. Okay, now remember this point. Questions are coming from this concept also. Don't neglect, even though these are very fundamental concepts but very important. Okay, right. So what is the first concept? Here our first concept is, yeah, representation of organic molecules by bond line formula. Let us take, this is concept 1. Yeah, concept 1, right? Representation of organic molecules by bond line formula. So how we represent by using bond line formula? Let us take one simple example, that like CH3 and CH3, this is the given molecule. So how to represent now this bond line formula? Okay, so for the representation of bond line formula, just I am taking like this. And you remember the one condition. One second, just before going to this, I want to go 3 points. These are very important. Okay, one second please. So in the representation of organic molecules by bond line formula, just you tell me this point, how we are getting what organic compounds? Organic compounds also known as hydrocarbons. Okay, hydrocarbons. Clear? Hydrocarbons. What is the meaning of hydrocarbons? Combination of hydrogen and carbon. Is it clear? Hydrocarbon chemistry, nothing but compounds are formed by the combination of hydrogen and carbon. Those are known as hydrocarbons. Okay. But in bond line formula, now remember this point, hydrocarbons are there. If there is a hydrogen, we are not going to write hydrogen. Don't write hydrogen. And we are not writing carbon atom. Very important point. Next one. For example, if CH is there, that also we are not writing. Understand? In bond line formula, don't write hydrogen, don't write carbon, and don't write CH. Okay, clear? And remaining any other given other than hydrogen, carbon, and CH, all the species we are representing in bond line formula except hydrogen, carbon, and CH. Now you write same point, very important point. In bond line formula, bond line formula, don't write, or in bond line formula, don't write carbon, hydrogen, and CH. Carbon, hydrogen, and CH. Okay. For example, if there is a CH, we are not writing CH. But if there is a OH, now we should write OH. Why? Because here hydrogen connected to other than carbon. For example, if there is a NH2, yes, here we are writing NH2. Why? Because here hydrogen present on nitrogen atom but not on carbon atom. Whenever there is a carbon, don't write. There is a hydrogen, don't write. And if there is a CH, don't write that CH. Okay, that is the first condition. Clear? Let us go to the examples. So once again, representation of organic molecules by bond line formula. What are the 3 conditions? Don't write carbon, hydrogen, and CH. Okay. Now come to this example. First and very basic example I am taking that. Now CH3 and CH3. What is the bond line formula for that? Next one, CH3, CH2, CH2, and CH3. Good. Next one, CH3, CH2, CH3. Okay. Once again, you better to take second example with 3 carbon atoms, CH3, CH2, and CH3. Very good. Next one, CH3, CH2, CH2, and CH3. Yes, these are the given molecules. First, let us start with very basic examples, right? Ethane. Okay, whatever the names, forget about the names that we will see in case of IUPAC nomenclature. Here we don't want any IUPAC nomenclature. Just you look at the molecule and write the bond line formula. What is the given molecular formula? CH3 and CH3. And you know that in that CH3 and CH3, first I am taking like this: hydrogen, hydrogen, and hydrogen. Right side, hydrogen, hydrogen. Here hydrogen. How many carbon atoms present? 2 carbon atoms are there. And how many hydrogen atoms? There are 6 hydrogen atoms. Okay. And what is the condition to write bond line formula? What is the condition? We are not going to write carbon, and we are not going to write hydrogen, and if there is a CH bond, that also we are not writing, right? But how to represent this molecule? Just I am taking like this. What is the meaning of that line? Now remember this point. Here two terminals are there, left and right side. Okay. Now these are the two terminals. Now just you observe this one. I am not at all writing CH and I am not at all writing carbon, no hydrogen and no CH. Just I am keeping one line. Okay. Now what is the meaning of this one? Left to terminal or any terminal, left or right side. Now terminal position or terminal atoms are carbon atoms. Terminal atoms are carbon atoms. Okay, terminal atoms are carbon atoms. And remember this point. For example, if more than two carbon atoms are present, remember this point. At each carbon atom take at each carbon atom take one sharp turn. Yeah, these are the very two basic points. Once again tell me this one. Terminal atoms are what? Carbon atoms. Yes, here how many terminals are there? Left and right. Here which is present? Yes, carbon. And here which is present? Carbon atom. And already we know that what is the carbon valency? 4. For example, here in this line, if already there is a carbon atom, by default according to the valency of carbon atom, here how many hydrogen atoms should be present? Even though you are not writing hydrogen atoms, but on this carbon atom how many hydrogen atoms should be present? By default there are hydrogen atoms. Remember this point. Whenever the molecule is given with less than carbon valency, to satisfy carbon valency 4, by default which one should be present on the carbon atom? Hydrogen. Okay, like that here also on right side carbon atom, yes, already left side one bond is there. To satisfy carbon valency, now we can write here like this: hydrogen, hydrogen, hydrogen. By default there is a 3 hydrogen atoms. Clear? Again you are getting what? Same formula, right? Yeah. So once again, terminal atoms are carbon atoms. At each carbon atom take one sharp turn, right? So directly I am going to write bond line formula for the given molecules. Okay, fine, right. Come to this first one. Just I am writing like this. What is the meaning of that line? Same thing. Two carbon atoms are there. Left extreme end is carbon, right extreme end is carbon, right? Between two carbon atoms how many bonds present? One sigma bond is present. By default, even though we are not writing hydrogen atoms, here how many hydrogen atoms should be present? 3. And here also 3. Just you observe this line. Here we are not writing hydrogen, we are not writing carbon, and we are not writing CH. Okay, right. So for example, if you want to write like this, yes, you can write like this, no problem. And you can write diagonally also, one and all same. All these bond line formulas representing ethane molecule, but generally for better convenient representation, in general we are writing like this, but you can take anyone, no problem, right? And come to this one. Here how many carbons present? 3 carbons are there, right? Now let us start from any terminal. I am starting from left side. Yes, I have a carbon. Just I am moving like this. Just I am going to stop here. And immediately, for example, if I are taking like this, now here one horizontal line. Okay, if we cannot differentiate the carbon atoms, okay, because of that reason we are taking sharp turn at each carbon atom. I am taking like this and immediately like this. Why we are taking sharp turn at this situation, at this point? What is the meaning? Now here, what about this point? Here carbon should be present. Here also carbon should be present. And why we are taking sharp turn? Whenever you are taking sharp turn, that indicating presence of carbon atom. So totally here by default, how many carbon atoms present? Now please tell me this point. How many carbon atoms present? First carbon, second carbon and third carbon atom. Okay, right. Now according to the next molecule, how many sharp turns we are taking? Except these two terminals, left carbon and right carbon atom. Okay, then how many sharp turns we are taking? Two sharp turns, right? Let me write this molecule. like this. Any doubt? Left side carbon, right side carbon, and for these two carbon atoms, I am taking two sharp turns. Just I am moving like this, immediate and again immediate. Okay. Now this is the bond line formula. Next one, come to another example here. Randomly, I am giving some molecules. Yes. CH3, next CH2, CH, here I am taking CH3 again, CH2, CH3. Write the bond line formula, right? And here CH3, CH, here I am taking NH2, right? CH2 and CH3. Yeah, these are the two examples. How to write bond line formula for these two molecules? Just we try to practice around 8 to 10 questions. These are sufficient. Then after that we will go for some other different concept, right? Now here let us take now this particular chain. 1, 2, 3, 4, 5 carbons are there. That I am writing here 2, 3, 4, 5. Is it clear? Now next one, at this carbon atom, extra methyl group is there, that I am writing here. Yeah, exactly. Third position, yes. This is the bond line formula. Clear? If you have any doubt, you can take numbering also, no problem. 1, 2, 3, 4, and 5 carbon atoms are there. Okay, right. Next, here also same thing. 1, 2, 3, 4, and 5 carbon atoms are there. At third carbon atom, extra this one, methyl group. Okay, right. Next one, how to represent this molecule? Here let 4 carbon atoms are there. 2, 3, 4. Yes, 4 carbon atoms, right? And here NH2 is present. We are writing hydrogen or not. If hydrogen is present on any atom other than carbon, then you should write here NH2. That is the way of writing bond line formula. Any doubt? Clear? Okay. Now let us go to next example. Yes. Now in this example, one second, I want to take few pages. Yes, 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 yes. Yeah. Yeah. Come to next example. One second. Yes. CH3, CH2. Here I am taking OH, CH2, CHOH, and CH3. Yeah, clear. Next one. For example, CH3, CH2. What happened? CH3, CHOH, next CH2, CHCN, CH3. Now convert these molecules into bond line formula. Yeah, okay, fine. Convert these molecules into bond line formula. I think for fundamentals nearly I am expecting that 3 to 4 hours time is required, but I complete each and every one. Yes, I am taking 1, 2, 3, 4, 5. 2, 3, 4, 5. Is it clear? And here which is present? OH, and here also OH. Don't miss hydrogen. Why? Because your hydrogen present on oxygen atom but not on carbon atom. That's why don't miss that hydrogen, OH and OH. And come to next one. How many carbons are there? 5 carbons. Now 2, 3, 4, 5. 1, 2, 3, 4, 5 carbons. At this carbon atom which is present? CN, right? And here CN. Sorry, here OH, here Cl. C triple bond N. Cn or C triple bond N. Anyone, no problem. That is the bond line representation. Okay, let me take one cyclic compound. Okay, CH2, CH2, and then CH2. Three member ring system, or CH2, 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 again CH2. Simple cyclic compound. Convert this one into bond line formula. Okay, right. Very simple. Just three carbon atoms are there. This is the bond line formula. Okay, I am not going to write hydrogen, carbon, and CH. That's it. Here four carbon atoms are there in the ring system. then simply here you write that 4-membered ring system. Clear? That is the bond line formula. And come to another example. Okay, some unsaturated systems like CH3 CH double bond CH2, and then CH3 C H double bond CH CH3. What is the bond line notation for this? Yeah, here 3 carbon atoms are there. Because of the presence of 3 carbon atoms, just I am taking like this bond line formula. Okay, no problem. You are not writing hydrogen, you are not writing carbon atom, and you are not writing CH, but don't miss pi bonds. Okay, here we are keeping pi bond. This is the bond line notation. Clear? Come to next example. Here 4 carbons are there, 2, 3, 4 carbons, and here pi bond is present. Okay, that is the bond line notation for the given molecule. Bond line formula for given molecule, right? Yeah, one more example by using some functional groups I am writing. Okay, right. Here this is the given molecule CH3, CH2, CHOH, and COOH. For example, this is the given molecule COOH. Clear? What is the bond line formula for this one? Yeah, totally 4 carbons are there. Just I am taking like this with 4 carbon atoms. Clear? Otherwise you can take numbering also conveniently. 1 2 3 4, 1 2 3 4. Here also same thing, 1 2 3 4, 1 2 3 and 4. Okay, 1 2 3 4, 1 2 3 4, 1 2 3 4. Once again, yes, at second position OH. Don't miss this hydrogen. And come to this first carbon atom. On first carbon atom, which one present? OOH, 2 oxygen atoms and uh, 1 hydrogen atom, right? Not exactly on the carbon atom. Actually, 1 oxygen atom is on the carbon and OH on the carbon atom. So we can write like this: double bond O, double bond O. Next one, OH, double bond O, OH. Now you observe this one. We are not writing any carbon. Everywhere we are not writing carbon atom, and directly no hydrogen and no CH. But if hydrogen is connected to oxygen atom, don't forget it. You write complete OH but not simple O. Here also same thing, OH but not simple O. Okay na? This is the bond line notation or bond line formula for a given organic molecule. Clear? Some previous questions are there. After completing these fundamentals, we will discuss those PYQs. No problem, right? Come to next one. What are the types of carbon atoms? Now second one, types of carbon atoms. Bond line formula completed. These are the rules. Now next one, types of carbon atoms. Types of carbon atoms. Very simple. Very simple. Throughout the organic chemistry we are using what are the types of carbon atoms, like 1 degree carbon, 2 degree carbon, 3 degree and 4 degree, like that. Okay, right? Here just I am taking like this. For example, if there is a carbon, here also I am taking carbon, carbon and carbon. Let your first carbon atom is connected with another carbon atom. Here carbon atom connected with 2 carbon atoms. Okay, don't think about other valencies. That whenever less than its normal valency given, directly we can use hydrogen atoms, no problem. And here I am taking carbon, carbon, again carbon. How many carbon atoms? 4 carbons. Here carbon, 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 again carbon atom. Okay, now you focus on this carbon atom. In first one, here how many carbon atoms are there? Now this carbon atom connected with how many carbon atoms? 1 carbon atom. That's why this one is taken as 1 degree carbon atom. In 1 degree carbon, carbon connected with 1 carbon atom. 2 degree, 2 carbons. 3 degree, 3 carbons. 4 degree, 4 carbons. Nothing is there. Very simple. Yes. Now let us look at this carbon atom. Connected with how many carbon atoms? 2 carbon atoms. What is the degree of this carbon? 2 degree. That's it. Next one. Here this carbon connected with how many carbon atoms? 3 carbon atoms. What is the degree of carbon? 3 degree. Bas 3 degree carbon atom, 2 degree carbon atom and 3 degree carbon atom. And come to this one. Now here this carbon connected with how many carbon atoms? 4 carbon atoms. Your middle carbon atom connected with 4 carbon atoms. That's why What is the degree of this carbon atom? 4 degree carbon. This carbon atom is 4 degree carbon atom. That's very important point. Once again you look at these carbons. When we call it as 1 degree carbon atom, if your carbon atom connected with 1 carbon, 1 degree, if carbon connected with 2 carbon atoms, 2 degree, 3 carbons, 3 degree, and 4 carbons, 4 degree carbon atom. Okay, right? Same thing. Yeah, we can write same points like this. Now, first point, 1 degree carbon, 2 degree carbon, 3 degree carbon, next one 4 degree carbon. Yeah, some special names are also there. Whenever 1 degree carbon is given, that is also known as primary carbon. Primary carbon, clear? Primary carbon. And this one secondary carbon. Secondary carbon, clear? Yes, secondary carbon. Next one tertiary carbon. Tertiary carbon, yeah, tertiary carbon. Next one quaternary carbon. Quaternary carbon, clear? So 1 degree carbon can also be called as primary carbon. Next 2 degree carbon secondary carbon. Next 3 degree carbon tertiary carbon, 4 degree carbon quaternary carbon atom, right? Now if you want to write, you can write these points also. 1 degree carbon nothing but carbon connected with 1 carbon. Is it clear? 1 carbon. See, nothing but carbon. Next, carbon connected, carbon connected with 2 carbon atoms. 2 carbon atoms. Here 1 carbon atom. Next one, connected, carbon connected with 3 carbon atoms. 3 carbon atoms. What is quaternary carbon? Carbon connected with connected with 4 carbon atoms. Clear? That is the meaning of 1 degree, 2 degree, 3 degree and 4 degree, right? Yeah, note down these points. As come to types of hydrogen atoms, clear? Yes, I am going to take, let it is 1 degree carbon. Carbon, carbon, carbon. 1 second. Next one. Types of hydrogen atoms. Okay, right. Types of hydrogen atoms. So to understand types of hydrogen atoms, simply I am taking like this: carbon, 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 and carbon. What is the meaning of 1 degree carbon atom? For example, if it is 1 degree carbon, 2 degree carbon, 3 degree carbon, and 4 degree carbon. What is the meaning of 1 degree carbon? Carbon connected with 1 carbon. 2 degree nothing but carbon connected with 2 carbon atoms. 3 degree nothing but carbon connected with 3 carbon atoms. And what is 4 degree? Carbon, 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 again carbon. Clear? Now, come to next point. I am going to take hydrogen atoms. Okay, which is the best color? Yes, I'm going to take hydrogen atoms. Just I am taking here whatever the number of hydrogens. Just here I am taking like this 1 hydrogen atom. Wait, let me use another color. Yeah, here I am taking hydrogen. Okay, whatever the number of hydrogens present, just you take 1 hydrogen atom. Here I am taking another hydrogen. Okay, if you want to satisfy valency, you can write like this, no problem. Don't get confusion. You can also write like this, right? Next here hydrogen, and what is the another valency? Again hydrogen. For example, already 3 bonds are there. By default, what is the 4th bond? Hydrogen. Here already 4 bonds are completed. Now let us look at individually here. Now in these cases, here hydrogen present on which carbon atom? 1 degree carbon atom. Then these hydrogen atoms are said to be 1 degree hydrogens. 1 degree hydrogen, 1 degree hydrogen, 1 degree hydrogen. Whatever the number of hydrogens present on 1 degree carbon atom, those are known as 1 degree carbon. Okay, so in general 3 hydrogens are there here. Next one, here we don't want number of hydrogen atoms. What is the nature of that hydrogen? Now this hydrogen present on which carbon atom? 2 degree carbon atom. Then what is the degree of this hydrogen? 2 degree hydrogen, 2 degree hydrogen. Next to this one, 3 degree hydrogen. Okay. Is there any hydrogen on this carbon atom? No. Why? Because already here valency completed. Maximum bonds are there around the carbon atom. Maximum 4 bonds are there. But is it possible to arrange hydrogen on this carbon atom? No chance. No hydrogen present. No hydrogen present on 4 degree carbon atom. Remember this point. Why? Because already 4 bonds are completed. Around the carbon atom, maximum we can arrange 4 bonds. Already this carbon atom connected with 4 carbon atoms. Then how can we arrange extra hydrogen atom? Not possible. Okay, clear. There is no 4 degree hydrogen. Yeah. Come to the same point. I am going to write same thing. Yes. 1 degree hydrogen, 2 degree hydrogen, 3 degree hydrogen, 4 degree hydrogen. But 4 degree hydrogen not possible. Forget about 4 degree hydrogen atom. Yes. And what is the meaning of that 1 degree hydrogen? 1 degree hydrogen nothing but hydrogen present hydrogen present on 1 degree carbon atom. 1 degree carbon atom. Next one. What is the meaning of 2 degree hydrogen? Hydrogen present on 2 degree carbon atom. Clear? Next one. 3 degree hydrogen. Hydrogen present on 3 degree carbon atom. Okay? And 3 degree carbon atom. 3 degree carbon atom. Okay? And there is no 4 degree hydrogen. So 1 degree hydrogen nothing but hydrogen present on 1 degree carbon atom. 2 degree hydrogen nothing but hydrogen present on 2 degree carbon, and 3 degree hydrogen nothing but hydrogen present on 3 degree carbon atom. Is it clear? Fine. These are the types of carbon and hydrogens. One second. Let me check. Yeah, 42 minutes are completed. Let us take up to 1 hour. Yeah. For example, if molecules are given like this, directly I am taking bond line notation. Yes. Here no need to worry about the names. Forget about the names. Here we don't want any names. Names are important only in IUPAC nomenclature. There are separate rules there. We will discuss very clearly. Then now come to this one. Okay, already OH also completed. Oh shit. Yeah. Yes, clear. Let me take one OH here and another OH. Yes. OH. Okay. Yeah. You look at this first one. Here my focus is what is the nature of alcohols in terms of degree. Here come to this first one. OH is present on which carbon atom? 1 degree carbon. Just you tell me this point. What is nature, what degree of that carbon atom? Degree of that carbon atom. 2 degree or 1 degree. Now this middle carbon atom is connected with 2 carbon atoms. That should be taken as what? 2 degree. Clear? Next. What is the degree of this carbon atom? Connected with how many carbon atoms? We know that carbon, carbon, carbon. What is the degree of this carbon? Yes, 3 degree. Okay. Now this is known as primary alcohol. Primary alcohol. Clear? This one secondary alcohol. Secondary alcohol. Secondary alcohol. And this one tertiary alcohol. Tertiary alcohol. Now remember these points. Tertiary alcohol. What is the meaning of primary alcohol? Primary alcohol nothing but this OH present on which carbon atom? Primary carbon atom. Next one, if OH present on secondary carbon atom, that is secondary alcohol, and OH present on tertiary carbon atom, then that is known as tertiary alcohol. These are the primary, secondary and tertiary alcohol. Okay, come to next one. Now we are using like this. Yes, somewhere I am taking halogen. Okay, whatever the halogen, there is no restriction. Either you can take fluorine, chlorine, bromine or iodine. Okay, let us start with the chlorine atom. Yes, chlorine, and here I am taking chlorine and here chlorine. Now just you look at chlorine connected carbon. What is the chlorine connected carbon degree? This one connected with how many carbon atoms? Only one carbon atom, that is what? 1 degree carbon. And here two carbons, right, left, 2 degree carbon. Here 3 carbons. What is the degree of this carbon? 3 degree carbon atom. Okay. So whenever your halogen present on 1 degree carbon, this is known as primary. That means 1 degree alkyl halide. Alkyl halide. Okay. When you are moving to halogen compounds, there we are using primary alkyl halide, secondary alkyl halide, tertiary alkyl halide, like that. That is primary alkyl halide. This one secondary alkyl halide. Secondary are 2 degree, both one are same. Primary are 1 degree, secondary are 2 degree, tertiary are 3 degree. Secondary alkyl halide. And what about this one? Tertiary alkyl halide are 3 degree alkyl halide. 3 degree alkyl halide. Clear? These are the different types of halides. 1 degree alkyl halide, or if you want to write chlorine name, you can also speak like this: 1 degree alkyl chloride, 2 degree alkyl chloride, like that. Okay, in general form I am writing like this: 1 degree alkyl halide, 2 degree alkyl halide, 3 degree alkyl halide. These are the 3 different types of halogen compounds: 1 degree alkyl halide, 2 degree alkyl halide and 3 degree alkyl halide. Okay, right. Carbon completed, hydrogen completed, oxygens completed, and halogen compounds are also completed. 1 degree, 2 degree, 3 degree, like that. Next one. Next one. Okay. Calculation of number of sigma and pi bonds. Otherwise, first. Okay, no problem. Next concept. Degree of unsaturation. We will discuss in the next class. Here, calculation of number of sigma and pi bonds. Very, very important. Calculation of number of sigma and pi bonds. Very simple. Just on the basis of carbon valency, we can calculate number of sigma and pi bonds. Okay, right. First, I am going to take simple example like this. What type of questions they are asking? They are asking first one, number of sigma bonds. Number of sigma bonds. Next one, number of pi bonds, or here you write number of CH bonds. Number of CH bonds. Here total number of sigma bonds. Third one, number of CC bonds. Number of CC bonds. How many number of CC bonds are there? Okay. To calculate all these things, now just you convert that bond line formula into, one second. Yeah, this is our given molecule. Yes. What is the meaning of these terminals carbon and carbon? At each sharp turn which is present, carbon. Just I am writing like this: carbon, carbon, carbon and carbon. Okay. By default, what is the carbon valency here? Carbon valency is 4. So by default here remaining valencies are satisfied by what? Remaining valencies are satisfied by hydrogen atoms. Okay. Even though they are not giving, we can take number of hydrogen atoms. Here carbon connected with one carbon atom. And how many free valencies are there? 3. To satisfy carbon valency 4, I am taking like this: hydrogen, hydrogen, again hydrogen. Is it clear? Fine. Yeah. Next one here, hydrogen, again hydrogen, right. Here already 2 bonds are there. We want extra 2 hydrogen atoms. And here hydrogen, hydrogen, again hydrogen. Clear. Now calculate the total number of sigma bonds. Now to calculate total number of sigma bonds, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These are the total number of sigma bonds. Yeah, first point I am writing total number of sigma bonds. Total number of sigma bonds equals to how many? Just you count these sigma bonds. I forgotten. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total number of sigma bonds equals to 13. Yeah. Second point, number of CH bonds. How many number of CH bonds present? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of CH bonds equals to 10. Next one, third one, how many number of CC bonds present? Carbon carbon bonds. 1, 2, 1, 2, 3 equals to 3. That is the way of calculating number of sigma bonds and pi bonds. Yeah. So one more simple example. If you are taking unsaturated system, right? In case of unsaturated system, any type of molecule is given like this, double bond, and here also double bond. So how to find number of sigma bonds and pi bonds? Just you calculate number of sigma and pi bonds. Okay. Again C and CH not required, right? Here first, by looking at this molecule, here how many carbon atoms present? According to the given molecule, how many carbon atoms present? Number of carbon atoms equals to 4. 4 carbon atoms are there. Clear. And we know that now at each carbon atom, basically what is the valency? 4. Already here two bonds are there, one sigma bond, one pi bond. Here also one sigma bond and one pi bond is present. Next one, how to fulfill that valence is, left side I am taking hydrogen and hydrogen, and come to this carbon atom. Three bonds already completed. Next we require one hydrogen. Yes. Here also three bonds are completed. Fourth bond definitely hydrogen by default. Here already two bonds are there. And what are the remaining two bonds? By default these bonds should be what? Hydrogen. Clear. Then first point. What are the total number of sigma bonds? Total number of sigma bonds. Yes. Total number of sigma bonds equals to how many? Total number of sigma bonds. One second, let me show sigma bonds. This one sigma bond, sigma bond, sigma, sigma. Here also sigma and sigma. And how many pi bonds present? Number of pi bonds equals to, one second. Yes, number of pi bonds. Pi again pi. Clear? Number of sigma bonds equals to, count number of sigma bonds, 1, 2, 3, 4, 5, 6. This one also sigma bond. Yeah, okay. Come back to same question, right? Here how many sigma bonds present? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of sigma bonds equals to 9. Second one, total number of pi bonds. Total number of pi bonds equals to, how many pi bonds are there? 2 pi bonds are there. Clear? Next one, if this is the given molecule, let us practice this one. Benzene molecule is given pi bonds are like this. Just by looking at, we can say that number of pi bonds equals to 3. Okay. Yeah. For example, these are the two molecules. How to find number of sigma bonds and pi bonds, right? Now here I am taking here three bonds are also already completed. I am going to take fourth bond hydrogen. Here also hydrogen. Next hydrogen, 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 again hydrogen. First point, total number of sigma bonds equals to, how many sigma bonds are there? Total 12 sigma bonds are there. Okay. sigma, 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 sigma. CC bonds, sigma, 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 sigma. Next one. Second one, total number of pi bonds equals to how many? 3 pi bonds are there. Clear? And once molecule is given like this, at the junction of these two rings, already carbon valency completed 1, 2, 3 and 4. Other than junction, so don't take hydrogen atoms at the junction of the carbon atoms. At other carbon atoms take hydrogen, yes, hydrogen, hydrogen and hydrogen. Here also same thing, hydrogen, hydrogen, hydrogen and hydrogen. Then count the number of sigma bonds. Here I am taking sigma 2, 3, 4, 5, 6, 7 and 8. 8 sigma bonds. Next 9 CC bonds, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. What are the total number of sigma bonds? Number of sigma bonds equals to 19. And how many number of pi bonds present? Number of pi bonds equals to 5. Number of pi bonds equals to 5. Okay, right. Yeah, that is a way of calculating number of sigma and pi bonds. And one more last example I am taking. Yeah, calculate number of sigma and pi bonds. Here how many hydrogen atoms we can use? Hydrogen, hydrogen, hydrogen. Here to satisfy carbon valency, hydrogen and hydrogen. Here hydrogen and hydrogen. Yes, hydrogen and hydrogen. Okay, right. Now find out number of sigma bonds. Number of sigma bonds equals to, next to, number of pi bonds equals to, yes. Come to this one, number of sigma bonds: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Number of sigma bonds equals to 14. So once again let me count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, right. And what are the number of pi bonds? Number of pi bonds equals to 2. Clear? This is the way of calculating number of sigma bonds and pi bonds. So in the next class we will discuss about what is the hybridization, what about the calculation of pure orbitals and hybrid orbitals, what is the ratio between pure and hybrid orbitals. Next, what is the exact meaning of degree of unsaturation and how to calculate by using different formulas in different compounds degree of unsaturation. Okay, right. And then after that we will go for what is the meaning of functional group and homologous series and types of hydrogen compounds in terms of acyclic compounds, cyclic compounds, heterocyclic, homocyclic, like that. Okay, na? Remaining in the next class.